there are other special cases involving trigonometric ratio, which is cosecant theta, which we called cosec theta is equals to 1 all over sine theta. Then another one is secant theta, which we call sec theta, is equals to 1 all over cos theta. And this one we call cotangent theta, which we also call cot theta, is equals to 1 all over theta. Okay, remember that theta is equals to, remember that sine theta is equals to 1 all over opposite over hypotenuse. So inverse of it, inverse of this thing, because this is inverse of sine theta, so inverse of it becomes now hypotenuse all over opposite. So cosec theta is equals to hypotenuse all over opposite. Okay, or you just say 1 all over sine theta. Okay, so which means you can get it from the triangle when you are considering this angle, which here is hypotenuse, here is opposite of this angle we are talking about, then here is the side which is adjacent to the angle, right? Now the same thing with this one. Remember that this will also be cos theta, means adjacent all over hypotenuse. So inverse of it, because this is inverse of cos, will now become hypotenuse all over adjacent. So sec theta, you can calculate sec theta by hypotenuse all over adjacent. The same thing with cot, 1 all over tan theta, which is inverse of tan theta. And we know that 1 all over tan theta means opposite all over adjacent, and the inverse of it will become adjacent all over opposite. Therefore, we can calculate cot theta with adjacent all over opposite, or 1 all over tan theta. Okay, then we also use what we call Pythagoras theorem to calculate the side of right angle triangle. Remember, right angle triangle involves triangle that has 90 degrees as one of the angles. So this Pythagoras theorem only considers the three sides. This side, this side, this side. He did not talk anything about the angles. The Pythagoras theory said that if this side of hypotenuse is A, this side of adjacent to this triangle, this side of opposite to this angle here is B, and this is C. Hypotenuse theorem says that this side of this Pythagoras theorem said that this side that is facing angle 90 is that side square equals to B square plus C square. He said that hypotenuse side squared is equals to B squared plus C squared, making A subject of formula. We now say A equals to square root of B square plus C square. So calculating for the side involving hypotenuse, which is A, we can now calculate the side involving hypotenuse, which is A, by using this side and this side. And you can also calculate any of this side. Like if you want to calculate for side B, it will now be B square equals to that side A square hypotenuse minus C square. Making B subject of formula, we now have square root A square minus C square. The same thing, making C subject of formula, we now have C square equals to A square, that is hypotenuse square, minus opposite square to this angle. Making C subject of formula, now have square root A square minus B square. These are the things I will use to calculate some questions involving right angle triangle before moving to sine rules and cosine rules. Okay, I will use some of this relationship, some of this trigonometric ratio, some of these formulas to calculate some questions, technical, basic and simple questions involving right angle triangle. Make sure you subscribe, follow, like the video, comment on it, share it, so that when I start calculating or treating some of the questions involving the right angle triangle, you'll be getting them. Thank you so much for watching, and God bless.